Good afternoon, everyone. We're just waiting for some more people to join. So I'm just gonna give everyone probably another 2 or 3 minutes, and then we'll begin. Still just waiting for a few more people, so just give us 1 more minute and then we'll begin. Okay, welcome to the first in our autumn series of webinars coming from the UK. This one's on residual limb health and lower limb amputees. There will be 3 presenters today, myself, Laura Ritchie, then we'll have Kate Davies and Dr. Mike McGrath, and then we also have Kate Pearce and Joe McCarthy on the panel. So they'll be able to answer any questions. First of all, everybody is on mute. If you can stay on mute throughout the presentation, that would be better for both the presenters and people listening. You can come off mute to ask a question at the end, or you can use the questions/chat panel on the right hand side. The webinar is being recorded and it will be available after the session to be listened to again, should you want to, over a romantic dinner. Or if any of your colleagues miss it, then they'll be able to listen to it too. As I said, if you do have any questions, please ask them on the chat. All questions will be answered at the end of the presentation. So we have people keeping an eye on the questions and we'll answer them all at the end. There are some handouts in the handout section, so feel free to download these. And then if any future webinars, there will be the link that you can see there. You can activate further webinars. If anyone does have any questions after the session or at any point, please feel free to email myself at laura.ritchie@blatchford.co.uk. So today we're going to talk about amputee biomechanics, so a brief overview of normal gait versus amputee gait and why we have some problems. Then we'll look at a review of the literature so far. We'll have some solutions to common prosthetic problems, and then have a look at the clinical evidence for the Blatchford technology solutions. And then we'll be able to open the floor for questions and or discussion. So I'm going to hand over to Dr. Mike McGrath, who's going to begin looking at the clinical evidence.
Thank you very much. So as Laura said, the key focus today is going to be on clinical evidence. So what is clinical evidence? It is scientific published information that can be used to demonstrate the performance and safety of a given prosthetic technology. But arguably the most important thing it can do is highlight the impact of that technology on the long-term health of the user. From scientific publications, we know that there are key secondary healthcare issues that are common for lower limb amputees. A focus of prosthetic design, therefore, is to create technology that helps to reduce the chance of these issues occurring. Today, in particular, we're going to focus on the issue of residual limb health. So, as Laura mentioned, the first thing we're going to do is consider amputee biomechanics. So before you can understand the effects of amputee biomechanics, it's important that we first understand how healthy biomechanics work. Then we'll see how amputee gait differs, what adaptations may be made to accommodate for these differences, and then what issues are likely to arise as a consequence of these adaptations. So before I start this, please forgive the drawings. I did the best I could. This is a healthy leg, and it's going through the motions of a gait cycle, and that is how a healthy leg walks. What I'm going to do this time is I'm going to slow it down, but also I'm going to pause at various phases and highlight the distance from the knee to the ankle. Now this might seem odd at first, but I promise I'm going somewhere with this. I do a lot of gait analysis, and when we do that, we use a rigid segment assumption between the joints, i.e. the structure between the knee joint center and the ankle joint center is assumed to be rigid. Therefore, the key thing here is that the distance between the two remains pretty much constant. Next, this is how a lower limb amputee might walk with a not particularly very good socket, but that's intentional to deliberately exaggerate and highlight the points we're trying to make. So this time I'm going to repeat what I just showed, but this time, as we did with the healthy limb, we're going to show distances. So this is the green arrow is showing the distance from the bottom of the socket to the sort of ankle of the prosthesis, and the red arrow shows the axis and orientation of the residual limb itself. So as you can see, as we go through this, the residual limb, the red arrow, has moved relative to the green arrow. This is an indication that the socket interface itself actually behaves like a joint with translation and rotation. So what does this movement mean? Well, rotation early on in stance phase can put a pressure point on the patellar tendon, for example, or you might get pistoning where the residual limb moves further into the socket and hits the bottom. More rotation in late stance, this time using the kick point at the anterior distal location there to help propel the prosthesis into swing. You may also see as the limb is lifted into swing phase, there is a slight separation, pistoning out of the socket of the residual limb again. And then at the end of swing phase, because of the inertia of the prosthesis, it may pull away from the residual limb, again creating this pistoning problem. And what I should emphasize here is that this is only in a single plane. There's a whole other third dimension to consider. And so in fact, this is what was done by Dr. Jing Tang at the University of Southampton in this work that he did, where he highlighted the joint-like behavior of the socket interface. So there's translation and rotation in 3 axes, which obviously affects prosthetic control. So when the socket moves down during swing, it means that the effective length of the leg is actually extended. From a safety point of view, this means that it could catch on the floor and cause a trip. In order to avoid a fall, patients will often compensate their movements. They might do this by hiking the prosthetic hip side up. They might plan to flex their feet during stance phase, as shown in the picture here, to vault and make that extra distance. Or they may circumduct the leg, which is on the prosthetic side, which is swinging it outwards in sort of an arc rather than swinging it straight through. Although these movements protect the user from damage in the short term, these kind of compensations have longer term effects. They can cause the body to move unnaturally so that the joints have abnormal forces going through them. These sustained movements over time put the user at much greater risk of developing chronic pain, such as lower back pain or even osteoarthritis in the joints of the sound limb. So with all that in mind, I'm going to hand you over to Kate, who's going to talk about the scientific evidence that exists around residual limb health.
Thanks, Mike. Hi, guys. So yeah, like Mike said, I'm going to take you through an overview of the literature that's available and then how it helps us make decisions on design and prescription. So when we do a review of the literature, there are about 30 papers that come up that relate to the health of the residual limb and where the effect of a prosthetic intervention is examined. Now, limb health has widely been regarded as a mechanical issue, so the vast majority of papers focus on methods of suspension and how to limit the in-socket movement, which leads to damage. As well, there's also a fair amount of research that looks at different methods of aiding wound healing following injury, which of course then leads back to suspension. Now, more recently, climate control, which is the temperature of the residual limb, has become recognized as being a major contributing factor. There are a fewer studies on it at the moment because it's a fairly new area of research, but that number is steadily growing. Now, climate control is actually a really interesting one because it affects not only the health and fragility of the residual limb, but it has massive knock-on effects on the other factors as well. So everything ends up being interlinked. So summing up, the contributing factors to residual limb health outlined by the review were socket suspension, wound care, and climate control. So I'm going to just have a quick look into these and take these a little bit further to see what the literature finds to be viable solutions for these. So firstly, we have suspension. As Mike showed earlier, the suspension method is a little bit more complicated than it sounds, as the residuum-socket interface can act like another joint, so we can see a lot of movement there. The aim of achieving good suspension, as you know, is to reduce this movement so the prosthesis behaves like a natural extension of the limb. Generally, it seems the primary focus has been around pistoning, that is the up and down movement within the socket that you can see in the video. Now, pistoning can affect patient safety and elicit gait deviations that have long-term consequences, but also in the short term, we know that the knocking of the stump within the socket can cause more acute damage. So types of suspension vary, and I'm sure you're all very familiar with them, so I won't go into detail. They're listed here in order of how efficient the suspension method is. Generally speaking, liner suspension is the most secure and also helps to cushion the skin and protect it from shear forces. So there are three types of liner suspension. We've got pin lock, passive suction, and elevated vacuum. That is suction suspension aided with the use of an active pump. Now, there's actually quite a lot of variability between liner suspension methods when we look at how the load is distributed. With pin liners, the load tends to be focused around the end of the limb where the pin attaches. So even when a total surface bearing socket is used, we still get that focused force. Whereas with suction methods, the load is distributed more evenly, meaning that the force applied to the limb at individual points is less, and you're less likely to get points of pressure. So load distribution is similar with both passive suction and elevated vacuum. But when studies look specifically at the amount of pistoning that occurs, a large difference is observed between them. Pin lock suspension elicited more movement compared to suction, with about 6 millimeters of movement compared to passive suction, which was just short of 3 mil. But the movement was reduced even further when we used elevated vacuum, which results in less than 1 millimeter of movement. So overall, assuming that it's suitable for the patient, the literature suggests that elevated vacuum is the gold standard of suspension. When injury does occur, though, it can not only be painful, but it can also interrupt or halt prosthesis use. Underlying conditions such as diabetes mean skin is more susceptible to damage, but the poor circulation in these patients also increases healing time, So when the skin gets damaged, it takes a lot longer to heal. So we have to look at ways to aid and to try and speed up the healing process so that the prosthesis use isn't interrupted. This is where elevated vacuum comes into play again. This study measured the wounds of several prosthesis users who used elevated vacuum suspension. They found that within 6 to 8 months, the wounds had not only reduced in size, but healed completely, and the patients were able to continue use of their prosthesis throughout. But it isn't all about suspension. Poor socket fit and componentry also cause damage by loading the limb abnormally. Because the prosthesis is a rigid structure, it's not able to adapt to uneven ground and variation in terrain, and it can't absorb the forces that occur during walking. So these are transferred through the prosthesis and onto the residual limb, usually at odd directions. If, however, the prosthesis can adapt to different surfaces and gradient, the limb can be protected from these abnormal forces and the chance of injury is reduced. Patients also tend to balance the loading of their limbs better as well. They're not in pain and trying to offload their prosthetic side, so are more comfortable putting weight through both legs. This further protects their joints in the long term. Now, climate control. As I said, it's a fairly new topic, but it is a really important one. We're all aware of sweat. Sweat is the main cooling system of the body, and the skin is able to adapt to different conditions. So, when the surface area of the body is reduced, like it is after an amputation, the remaining skin sweats proportionally more to achieve the same amount of cooling. Generally, people with amputation exert more energy than able-bodied individuals performing the same task. This increase can actually be anywhere between 10 to 40% for a unilateral transtibial amputation. This means that they get warmer, so the body sweats in order to cool itself. But the body is already sweating more because of the reduced surface area. So the combination of these two factors mean that people with amputation sweat a lot more than able-bodied individuals. Now, you might think, a little bit of extra sweat, can it really be that bad? Well, the thing is that usually sweat just evaporates. That's the whole point. But if you're wearing a prosthesis, you have layers on top of the skin, so the sweat has nowhere to go. It's like having to wear rubber gloves all day without taking them off. As you can see from the video, the results are less than ideal. But here's the crux. We've said generally liner suspension is the most effective. Prosthetic liners are usually made from gel or silicone, which is great when it comes to cushioning and protecting the skin from damage, but it also means that they act as insulators and they increase the temperature, making the sweating problem even worse. The material is also non-permeable, so that any sweat that is expelled is then trapped against the surface, and you get a situation like you get with our cyclist in the previous slide. Aside from the fact that it's uncomfortable and smelly, this is bad for two reasons. One, the moisture acts as a lubricant, meaning that the liner is more likely to move and slide on the skin's surface, causing friction. And two, sweat clogs the pores, resulting in skin rashes and infections. It also makes the skin wet. Now, that might seem fairly obvious, but prolonged exposure to moisture affects the actual structure of the skin cells, kind of like what you see in trench foot. This makes the cells more susceptible to damage from friction, which we have more of because of the moving liner. Now, there is a danger of all this being purely speculation, so we tested it. We made an artificial limb that had small holes in it that acted like pores in the skin. We then put a standard liner and socket on it and mounted it in a compression machine. The machine oscillates the limb up and down to simulate walking, and we measured how much the limb moved within the socket. We repeated this, but injected water into the limb, which traveled through the holes to the interface between the limb and the liner, simulating sweat. You can see from the graphs that there is a lot more movement in the sweating condition. There's also evidence of an increased prevalence of skin conditions within the population of prosthetic users. A study in America tracked 520 patients, which, on a side note, is a huge number in a prosthetics research world. And they found that 41% of the entire population had some kind of skin issue on the residuum, and a quarter of those conditions were ulcerations, which, as we know, can be very serious. So we know the main causes for the residual limb deterioration and also some possible solutions. So I'm going to pass over to Laura, who can tell us a little bit more about some of the technologies that can help combat these.
Thanks, Kate. So when we think about suspension, studies have shown that amongst other benefits, suspension is enhanced with elevated vacuum, and with amputees reporting that the prosthesis feels more attached and that they have more control. And that's partly because of just having better suspension, but also due to the effects of elevated vacuum. If we consider loading and wound care, it's also well established that vacuum promotes wound healing. We see this in the ward environment for any patient, whether they're an amputee or not. We see that the effects of putting vacuum on a wound have. So in amputees, this is no different, but we also know that having movement at the ankle, i.e. having a hydraulic ankle, this also reduces peak loading when we compare this to a fixed ankle. And if we think about the climate, there are various medical solutions to reduce sweat from the residual limb, but these are generally quite invasive, or they use chemical solutions that aren't ideal for skin and tissue absorption. So when we think about prosthetics, we need to look at other ways to control the climate and technology to promote better sweat management. And this technology will be discussed in the next couple of slides. So the first device that we're going to talk about is an EchelonVAC foot by Blatchford. So this video is an animation of the foot, and it's a combination of a hydraulic ankle and elevated vacuum. And the really cool thing is that if you think technology is cool, but the cool thing I think is that we found a way to do both things within the one unit. So as you can see, like in loading response, as the foot plantar flexes, air is drawn out from the socket via the one-way valve. So the one-way valve is the connector. You can see the two tubes on the left-hand side, and then there's a sort of pink unit within a black unit between them. So that's the one-way valve. So air is drawn out of the socket by the foot plantar flexing. And then as the user progresses through stance, the foot dorsiflexes from mid-stance onwards, which then expels the air back into the environment using the same valve. And the air is stored in a small chamber, which you can see in pink at the bottom of the ankle. So the air is kept in there and then released back into the environment. So therefore we get the benefits of improved suspension, while the more secure fit also ensures less chance of skin breakdown. And we love graphs at Blatchford. I personally find them confusing, but this graph effectively is showing the difference in vacuum levels between passive vacuum and elevated vacuum. So passive vacuum is the darker colour. To me it looks black. I'm told it's blue, so let's call it an octopus ink colour. An elevated vacuum is in green, so the green one at the lower part of the graph. The x-axis is time, so while the amputee is walking. In this case, we've got a snapshot of 5 seconds, so it's 5 seconds of amputee gait. And the y-axis is vacuum pressure in inches of mercury. So the main thing to take from the graph is that a more negative value means a stronger vacuum. So we are looking for a more negative value. And you can see in the elevated vacuum, so the green part, that the peak vacuum is just under 14 inches of mercury, while in the passive vacuum, the peak vacuum is just under 8 inches of mercury. So we have a stronger vacuum with the elevated vacuum. But you can also see the difference in pressure. So the black line, or the octopus ink line, which is the passive vacuum, we have a range of just over 9 inches of mercury between the strongest vacuum and the weakest vacuum. But when you compare this to the green line, so the elevated vacuum, then there's just under, the range is just under 3 inches of mercury. So this effectively means that there is less pistoning when the elevated vacuum when compared to the passive vacuum. And then if we look at just the hydraulic ankle on its own, on the left-hand side of both the pictures, we can see what happens with a fixed ankle. And then on the right-hand side, which we'll talk about in a minute, is what happens with the hydraulic ankle. So on the left, we have the foot springs, and the rigid ankle effectively behave like an actual spring, like a coiled spring. So when they're compressed, the spring wants to return back to its equilibrium point relatively quickly, which then results in the anterior distal and the posterior proximal peak pressure points as shown in the diagram. For uphill walking, so what you can see is level ground walking at the top and obviously downhill walking at the bottom. For uphill walking, these peak pressure points would be in the opposite. So it would be anterior proximal and posterior distal. With a hydraulic ankle, the foot and the ankle complex together behave viscoelastically, which effectively means that peak loading is absorbed more readily by the prosthetic technology, which therefore results in less pressure around the residual limb. And if we think about just our climate, so we know that we can try to, what we want, well, Kate said that with liners, we know that provides shock absorption and cushioning. So we like to use liners, but then it creates heat and it acts as an insulator. So how do we get the best of both worlds? Well, Blatchford came up with some perforated liners to try to reduce the accumulation of sweat, but still have enhanced comfort from having a silicone liner. And you can see in the top picture, when we cannot control sweating, the chances are that the pores become blocked, and you can see that there's a yellow mass around the top of the pore, whereas in a more controlled environment, we can reduce the likelihood of this and therefore allow more ventilation through the liner, which therefore keeps the skin healthy. So the liner that Blatchford designed is called the Silcare Breathe liner, and there are two liners. So we have a cushion version and a pin version. So these are both silicone liners which have holes drilled in them throughout the liner in order to make perforations. And the videos show how the liners work. So with sweating, can you play the video again, Mike? With sweating, we would typically expect sweat to be collected distally, so it would pool distally, and therefore the holes are drilled at the distal end as well as the sides of the liner. So in loading, what we would expect is that air and sweat are expelled through the holes, either through the distal holes or through the sides, which keep the residual limb dry. And this was easier to design in the cushion liner because the addition of a suspension sleeve means that air doesn't get back into the system. Whereas in a pin suspension, if that's the suspension method of choice, we don't have a suspension sleeve, and therefore it was harder to create this one-way valve effectively. So the valve was added distally. So on the animation on the right, you can see there's a kind of brown valve shape at the umbrella of the liner, just where the pin's coming through. And again, in loading, the valve opens, so air and moisture can be expelled, and then the valve closes during swing, so it means that air doesn't get back into the system. So it's all very well me talking about how it works. We obviously had to do some internal trials. This was done in through our head office in Basingstoke, which none of you probably know where that is. But what we wanted to do is subjective feedback is important as well as clinical feedback. So I've certainly seen that patients might respond very well to a type of technology, but actually the benefits aren't measured quite so much. Can't see in a clinical perspective where we're measuring outcome measures, we don't necessarily see a difference. However, it's still important to have the subjective feedback, because at the end of the day, if an amputee finds that a device helps them, then it doesn't really matter if we can't actually see that in a gait lab or through some outcome measures. So when we did the trials internally, the subjective feedback was positive. The chart on the left shows the number of participants who reported sweating within the prosthesis. So in this case, there's 17, and they all had, at fitting stage, they all had issues with sweating. After a month, we had 8 out of 8 responses. 4, so 50% still had issues with sweating, but the other 50% reported that the issues of sweating were either greatly reduced or they only had it when they were exercising. I don't know what type of exercise that would have been, so I would imagine it would be when they were running or doing something a lot more vigorous than walking. And although the numbers at the 3 and the 6 month reviews are reduced in terms of the feedback, everyone still reported an improvement. The chart on the right was asking people whether heat or sweating in the prosthetic leg stopped them from wearing it. So of 8 participants, or 8 amputee feedback charts, we found that at fitting stage, all 8 said that this was a problem. So in other words, when they started sweating or when they overheated, they had to stop wearing the leg or stop doing the activity that they were doing. And after 1 month, just three of them were reporting the same issue. So it meant that 5 of the people had definitely had a benefit to having the sweat management technology. At 3 months, all of them, there were no issues with sweat. There's a little blip after the 6 months where one participant so said that they had an issue. However, that particular participant that went in line with their mobility was also increasing. So they were actually able to do more things and participate in more activities. And so although it looks negative after 6 months, it was actually seen as a positive because they were able to participate in more activities. So I'm going to hand you back to Mike and Kate, who are going to look into the specifics of the Blatchford technologies and look at the benefits or the clinical evidence for the technology.
Thanks, Laura. So as Laura's just shown, we saw how hydraulic ankles can work with elevated vacuum systems to provide better suspension, but they also add the benefits of ground compliance too. Now we know this is a factor that can cause unnecessary loading of the limb, but this has also been proven in published literature. So hydraulic ankles have been shown to reduce the pressure on the residual limb in certain anatomical locations by up to 81%, and reduce the rate of loading by up to 87%. That depends on what surface is being walked on. But all of the changes are, I think there was 6 different surfaces that were measured in that study. And all of the changes reduced it by over 60%. So that was quite a significant finding. In addition, elevated vacuum has also been shown to reduce pressure on the residual limb by helping to keep the load more evenly distributed across the whole surface area. Therefore, the combination of elevated vacuum and hydraulic ankles has the potential to dramatically reduce the risk of injury to the residual limb. Whether or not the suspension is of good quality, pistoning and poor socket fit can still occur because of changes in the residual limb shape. So total limb volume often reduces throughout the day as fluid is pushed out by the movement and compression of the limb against the socket. When the limb volume shrinks, it affects socket fit. And movement often occurs in the afternoon, even if the fit was of good quality in the morning. Elevated vacuum creates a pressure differential around the limb, which helps to circulate fluid and maintain volume so that socket fit stays the same. This improved circulation has other benefits too. Oxygenation and hydration, both of which can be compromised by damage to the skin structure, are both retained with long-term elevated vacuum suspension use. This particular image here shows the difference in oxygenation of the residual limb tissue. So an area of coloured blue indicates high levels of oxygen in the tissue, while a red area indicates a deficit. So when using elevated vacuum suspension, which is the bottom two squares there, there was a retention of the level of oxygenation of the tissue, whereas using different suspension methods before a particular activity occurred, there were high levels of oxygen, but then post-activity there was a loss of oxygenation, which clearly has got health implications for the tissue itself. Yeah, so basically you get a more consistent suspension and tissue health by using elevated vacuum.
If we look further into tissue and skin health, a study looked at the prevalence of skin issues found on residual limbs in patients with different prescriptions. It measured the health of residual limbs in patients using the Silcare Breathe perforated liner when compared to a control group using standard liners. The graph on the left shows the different skin issues that were reported by participants and what proportion of each group was affected. The control group are in red and the Silcare Breathe users are the green bars. So you can see that the perforated liner group reported significantly fewer issues overall, and the occurrence of individual issues also dropped. Chafing was cut by almost 50%, which you'd expect if the liner isn't moving as much. Fungal infection, callousing, and abscesses weren't even seen in the study group, even though some of the users had previously suffered from these issues before changing their prescription. In addition, the graph on the right shows that Silcare Breathe users scored higher on the prosthesis evaluation questionnaire when asked about the overall health of their residual limb. The same study also investigated pain, both physical and phantom. The graphs show how often individuals experienced each type of pain over the period of 1 month. The x-axis is the frequency, and the y-axis is the percentage of the population that selected each category. The frequency ranged from never to every day or all the time, so a skew to the left is better. You can see that the green bars, which are the perforated liner users, have a clear skew to the left, denoting that they experienced pain less often. In fact, patients reported significantly less frequent pain both in their residual limb and their phantom limb when using the perforated liner. Now, Mike's already talked about the combination of hydraulic ankles and elevated vacuum. However, the given benefits seen by these technologies, there are also likely to be benefits by combining vacuum with perforated liners. I think Laura mentioned earlier that negative pressure dressings are widely used in post-operative patients with great results. I'm sure you've all seen them. Elevated vacuum creates the same negative pressure. The perforations in the liner allow that vacuum to act directly on the skin in order to promote healing. There's further evidence of different combinations of these technologies that can be seen in a paper published last year, looking at 3 different case studies. The first uses a Silcare Breathe locking liner. The second used Silcare Breathe with a passive vacuum suspension, and the third used a Silcare Breathe liner with elevated vacuum and a hydraulic ankle. Each case had chronic skin conditions to begin with 2 actually considering revision surgeries. But by choosing the right combinations of technologies for each patient, their clinicians were able to find a setup that worked, and each patient saw that their problems cleared up in a few months, while still being able to continue daily use of their prosthesis. So that's us. I'm not going to go through and read all those notes. It basically covers all of what we've kind of talked about today. If you are wanting a bit more information, the residual limb health white paper that's identified there is in the handouts. If you look at the handout tab, and we've also got a white paper on hydraulic ankles as well. Any links to the various papers we've mentioned as well will be sent out in the email following up from this webinar. Oh, and they're also there as well. So yeah, I guess it's time to open it up to you guys if you have any questions.
So we have had a couple of questions. Joe, you could maybe answer this one, and then Kate, you could okay, Pearce, you could answer the next one. The first question is, do you need to have a one-way valve on the socket to use the EchelonVAC?
The short answer to that is yes, and ideally one that like allows air to expel from it automatically as well, to get the any air out of the system in the first place very, very quickly, to allow the action of the ankle, the vacuum, to draw the vacuum out from the socket. So yes, it's quicker, and an auto expel valve on there is probably the best thing to have on there.
Okay, thanks. Joe, what if someone has a comfortable socket and they don't want to make a new one? Could they use it in the short term with the EchelonVAC?
Yeah, that's not a problem. I mean, I would put a one with like a 90-degree barb on there and go straight down, you know, put a one-way valve just below that, like a fish tank valve, so that if there's a break in the pipe down below there, we still maintain, or that person still maintains vacuum, they don't lose the leg. So literally 90-degree barb coming out of the socket, you know, so that's not going to affect anything at all. Down, one-way valve very close to that, and then literally run down from that to the valve block of the EchelonVAC is what I would do.
Okay, thanks. And Kate Pearce for another question about the Silcare Breathe, I think it is. Do you have to use a particular suspension sleeve with the Silcare Breathe? Do you want to answer that one?
Yeah, thank you, Laura. You can use any suspension sleeve with the Silcare Breathe liners, just whatever is best for your patient. If you're going through, if you want to have a think about what type of vacuum you're going for, you could perhaps try the Viva sleeve that we get from Alps that has its own vacuum valve imprinted into the sleeve, or you can have one inbuilt into the socket. But yeah, anything you fancy really. We also have the pre-flex sleeves, which are quite comfortable, and it just stops all that popliteal bunching at the back of the liner and the sleeve, so it's a little bit less build-up for your patient, so it's a lot more comfortable.
Yeah, I think where it could have been coming from, I know in some markets they say that, you know, you've got a silicone liner, you've got to have a silicone suspension sleeve and that sort of thing. And I think some of that probably comes from different manufacturers of vac pumps. And I know some of them are adversely affected by the mineral oil that comes out of things like Alps liners, no sort of gel liners like that, or gel suspension sleeves like that, because that can adversely affect the seals and other things in the system of other pumps. But certainly I know on our evaluations that we had people using Alps liners, Alps suspension sleeves, and obviously mineral oil in those, and you know, there was no problem with any of them at all. So I think that question could have been coming from that angle as well. Okay.
Okay, thanks. Just a reminder, if you do have more questions, please put them on the questions bit. So just ask on the, there should be on the right hand side, there's a thing from the GoToWebinar, and there's a section for questions. So if you have a question, you're not sure how to ask it, you just go to the questions bit and it will open up a drop down menu, and then you can type in your question there. We've had another one, Joe, maybe do you want to take the lead on this one, about what's the vacuum pressure? So again, this is for the EchelonVAC.
I mean, typically we can get down to about 15 inches of mercury, which is normally more than enough for most people. And I mean, I know some of the systems go up to sort of 23 inches of mercury, but other, you know, the vast majority of people, you know, in the 12 to 15 inches range of mercury, vacuum, I should say, is what they really like. Beyond that, like I say, sort of, some people can find it uncomfortable as well, but above that sort of level. But certainly it'll vary according to the person. Generally, you know, if somebody's more active, like a younger, more active person, they'll want more vacuum. Older, more sedentary people, you know, perhaps with a bit more sensitive residual limbs, they might want a bit lower pressure, generally speaking, is what I would have answered that with, Laura. Okay.
Okay, thanks. And another one, sort of elevated vacuum in general. I'm sorry, I'm just reading the question. Yeah, for elevated vacuum, are all amputees suitable, or are there contraindications to using the EchelonVAC?
Me?
Anyone?
No.
Yeah, you take it.
I mean, certainly, if somebody's varying, sort of like if the residual limb's varying a lot, you've got to be very, very careful. Like if someone's on dialysis, their limb volume can vary a lot. So I would be very, very cautious. And obviously, the people that are using elevated vacuum, they need to really, I was going to say play with a full deck, but that's not the right thing to say, is it? They need to have good cognitive ability to understand what's going on and recognize if the leg's not fitting, why it's not fitting, what's going on. And, you know, like anyone, they should inspect the limb at least once a day, you know, the residual limb, just to make sure everything's all right. So good cognitive ability, make sure that certainly, you know, they're not fluctuating a lot. You know, those are things those are the sort of people I wouldn't put on it to start with. I would try and get the limb stable. If you've got, I mean, I've known people who've maybe as diabetics, for example, who fluctuated quite dramatically, and I think it's important to get them to a stage where, you know, their limb volume is as stable as it can be, and obviously using compression stockings and things like that to actually get it. And you know, it's important as well when you cast these people that are fluctuating a lot, cast them at the right time of the day, you know, so later on the day when the volume's actually out of their limb, out their residual limb, is the sort of time I would be looking for that. Kate, have you got anything else to add?
I'd just say if you were considering using it with the Silcare Breathe liners, invaginated scarring is a bit of a contraindication, just because it can create an air track and can reduce the elevated vacuum inside the liner.
Yeah, and obviously the socket that you use has to be total contact, no voids, you know, that you cannot have any voids, otherwise the residual limb tissue will be drawn into those areas. I was taking that as a given, but I shouldn't have done.
Another question, I think, to either Kate Davies or Mike, it's about in the evidence for skin issues. Was there a particular period of time where you started to see the improvements? Sorry, I'm trying to. Yeah.
So in the trial, the issues were kind of measured over a 12-month period. So within that 12-month period, we took an original kind of base measurement at 0 months, say, and then we had 1 month, 3 month, 6 month, and 12-month updates. So that is actually over a 12-month period, but it's also generally we tended to see kind of an improvement from 1 to 3 months as well. Generally, people who had kind of issues or who didn't have issues by the end, those issues had kind of gone by about the 3 to 6 month period. But I mean, yeah, it's individual as well. It depends on the individual and how much they're doing and what their stump health was like to begin with.
Just to add to that, I think, Laura, if you're referring to the images we showed earlier, hang on a sec, I might be able to whiz it back to the picture. There we go. Yes. So these particular case studies, most of these people saw improvements within about 3 months. Like I think Kate said when she was describing this, there was the two of them, the top two were actually considering revision surgeries. And after a month, both had sort of postponed that and then finally decided to cancel it. But there's much greater detail within this paper, if I can give that a cheeky plug as well. But yeah, so approximately about 3 months, you'll be able to tell a difference.
The other thing I was going to say was, I mean, sort of on that, I mean, we saw some of these on the evaluations when we were doing just the ordinary Silcare Breathe liners before we actually started putting elevated vacuum on them. And there was some people there who their stumps, their skin condition on the residual limb was starting to improve quite dramatically just by virtue of having a dry environment in there. And then there was others that improved further when we introduced elevated vacuum, you know, and tried to, and I think that was, a lot of that was down to stabilizing the limb volume within the socket, maintaining the socket fit, less relative movement. And I think that's one of the biggies that we see, a lot less relative movement with elevated vacuum. And all right, it'll take a couple of steps to get that vacuum up to a reasonable level, but the people can normally feel it within literally 3 or 4 steps. They'll start to feel, hang on, that vacuum's starting to crank up already. It might take significantly longer to get to sort of 13, 14 inches, but the people do feel that vacuum pretty well immediately.
Just to add on to that, I should say that the top image you can see on that slide there, that particular user was just using a lock-in Breathe. So he just had the pin lock version of the Breathe liner on. So no elevated vacuum for him, and yet he still saw the same improvements.
Yeah, so the dry residual limb does make a big difference on its own, and I think that's where, you know, we're lucky with that to be able to see those sort of improvements.
Unless anyone has a last minute question, Mike, would you mind putting the last slide up? So if anyone has any questions, there are ways that you can contact Blatchford. You can obviously get a lot of information from the website. I think if you go to the website from memory, on the top right hand side of the homepage, there's a section for professionals, and you can click on that, and there are some links to some of the evidence for residual limb health. There's other things on hydraulic ankles, so feel free to have a look. I don't think anyone's really going to be tweeting, but if you are an avid Twitter user, then we do have at Blatchford Group, so you can have a look at the things that we tweet about. I have an account, but hardly ever use it. And any other questions, either by email, you can send them straight to Blatchford, or you can use my email address and I can direct them on. So thank you very much, everybody, for joining from whatever part of the world that you're in. It's been raining all day in London. I hope it's better with you, and we'll see you for one of our next sessions, which I think is on the 3rd of November. We're doing something on hydraulic ankle sort of setup and alignment, and then there are a few more, so you can register in the same way that you did for this one. But thank you for joining. Have a good day, take it easy, and